This is the fifth in a series of modules about productive tutoring techniques. You, the viewer, will have an opportunity to see actual tutors handling real tutoring situations. These scenes will benefit you the most if you take time to think about and discuss what you see. Throughout this module, this screen will appear as a prompt for reflection and discussion. Student verbalization provides a variety of benefits for both tutor and student. Let's look at some. First, an open conversation is needed for ideas to be freely shared between tutor and student.
So what do we need to do?
This was reduced going this way.
Right.
And it needs to be oxidized. So we have to reverse it.
Right.
One of them's always going to be reversed. No?
Well, unless they give you like one from up here and one from here.
Then it's okay.
Then it's okay. But you just
if
need
they're both
to,
positive or both negative.
right, you need to just look and see what's happening, and then you can decide whether it needs to be reversed or not.
Now, what is the crest-to-crest separation?
I'm talking about like right here, right? Where it goes, here's one.
Right.
And it goes down or whatever, but then it's from here to here. Right?
Right.
This is my
But
picture.
yeah. But what is it?
The distance from the top of one wave,
Which
the
we
highest,
also call...
the crest. No.
But what's that distance also called?
Between here and here?
Between two crests. Or two troughs. Or
Let me draw a period,
Okay.
a picture here. Okay, that's a period.
But what's the distance?
Between here?
What's it called?
What do you mean, what is it called? Wavelength?
Yeah, exactly. Right.
When the session has a true conversational structure, the tutor and student will be able to negotiate the meanings of difficult concepts, as seen here in the back and forth discussion between Jessica and her student.
This is two separate functional groups that happen to be on the same molecule, and so the whole molecule is an amino acid.
Okay.
Okay, do you see that?
Yeah.
Okay.
So if this was separated by a bunch of other molecules, it wouldn't be an amino acid. Is that right? It would be carboxylic
Now, if it
acid.
still had a bunch of other atoms in between, it'd still be an amino acid. But, and see, that's the difference. If this was separated in between here by a bunch of different things, then it wouldn't be an ester. It'd be a carboxyl and an ether.
Okay.
See this thing? This is only an ester when they're right beside each other.
And this is only amino acid when they're not right beside each other.
Well, they can be right beside each other.
And still be an amino acid?
Like if you didn't have your C here, if it was just NH2, then it would still be an amino acid, because it would still have your amine group and your carboxylic acid group.
Okay. So when would it be an amine and a carboxylic acid?
If they're
Whichever.
if they're on the same molecule, the whole molecule is an amino acid.
Okay.
Can you kind of see what I'm saying?
So it would never be separate. There would never be these two different functional groups on the same molecule. Anytime they're on the same molecule, it would be an amino acid.
Right.
In order to speak in sentences, our somewhat fuzzy ideas must be sharpened to meet the precise demands of spoken English. Speaking, then, becomes a way of learning. Jason seems to be aware of this. Watch as he encourages his student to describe the physical differences between the equilibrium and the boiling point situations.
So is that an equilibrium?
No.
And that's what? Vapor or boiling point?
That's your boiling point.
Right.
Okay.
But what's happening at the vapor pressure?
That's when your liquid and your gas are equal.
Yeah.
Okay.
Say a little more detail.
Like that's when your liquid and your gas are in equilibrium.
Which means, I mean, yeah, you can
That
say that's
means
equilibrium,
how
but what's
much-
really happening?
All the liquid that goes to gas, then you have that much gas coming back to your liquid.
Right.
Okay.
Let's watch some other examples of students clarifying their thoughts by verbalizing.
That kind of like the conjugated and this is kind of conjugated if you like spread it apart, but this is
not cumulated. It's
the accumulated is the least stable. It's the isolated. So this would kind of be like that if you'd spread it apart.
right.
But if there was one right here, it would be more like accumulated one.
The Ka for the acid is 1 times 10 negative 14th divided by the Kb.
Right.
Is that right?
Yep.
Okay, and this one, it's talking about if you have like this formula, like instead of HCl you had XOH, which is what they had there. And what we were saying before with that HCl is this hydrogen will leave easier if this bond is stronger, or if this is more electronegative and it pulls all the density over here.
Right.
So this is, I'm in a small boat heading directly toward the sound. Okay, so this is the velocity of the detector, myself. Okay.
Right.
That is 4.6. Okay. And and a constant speed. Can I assume here that S is not moving?
Right.
Because
It
they
says-
didn't say anything. They just
Right.
said it's moving at a constant speed, which means it, you know, okay.
Right.
So the velocity of the source is 0.
In the process of verbalizing, students often become aware of the specific point on which they are confused. Also, they may realize what they need to do to overcome the problem.
Okay, because it's saying that equals Q, which
Right.
is heat.
Yep.
So your heat equals the heat of the product minus the heat of the reactant. Is that what that means? Okay.
Do you understand that?
Yeah, it's just another formula I need to learn.
Very small amount left.
Okay, right.
I think my problem was I didn't
Didn't
do
to the fourth.
I didn't write the KSP outright reaction or whatever.
Okay.
You know what I'm saying? Like I just did 0.40,
Okay.
and I need
Right.
to make sure that I take the
Yeah, because
the
this is
formal.
solubility always, you
Always
have to
have to do
raise it
that.
to the fourth
Okay.
power or whatever.
Okay. And it says the two things that determine that are the oxidation state and electronegativity. And I understand the electronegativity part, why that would pull away, but the oxidation state.
With this type of information, Tanaka and Senka went a little bit further in the research by trying to see if a face was different in a particular area, would one be able to recognize it? I don't think this is a good punctuation phrase. And I had a problem with it. I put in a particular and still it just doesn't ring right.
Sometimes the verbalized thoughts of the student turn into questions. If the student had not been verbalizing, these questions may not have ever been asked.
And then I guess this right here, the mechanical, is just another way of saying your work. Isn't that another way of describing?
Basic unit of energy is joules. It is a small unit of energy. Mechanical and thermal. Yeah. Yeah.
Okay.
Well then, so one's a factor you take, I mean, where does that leave you? Where do you go from there?
Okay, what did your division tell you?
0 is a remainder?
Okay.
I know that these are the electrons that would have to leave.
Right.
Because these are the only extras.
Right.
Why wouldn't it come from a pi bond?
Well, okay, we're gonna look at that now. Now, when this oxygen pulls this hydrogen over here,
Oh, so this is actually coming over here.
right, it'll form a bond there.
Okay.
Everybody's done it. You begin to ask a question, and by the time you've put most of it into words, you've discovered the answer. In such a way, verbalization helps students find their own answers. Let's see some examples.
Times 930. 945. Okay, now this, why is this number higher than, oh, it's coming towards me.
Right.
Okay,
Okay.
that was easy.
So that was just 3
Alright.
plus 8,
Right.
which is 11.
Wait a minute.
Wait, that should be 5.
Yeah.
I don't know where I got 2 from. I looked at that. Which is that 125?
Yep.
Which would make it 128.
Alright. 1% negative 2 because we have 1 over 4 is equal to 16. So you multiply the negative 2 out of that. Right? Negative 2 times 2 would be negative 4. Oh, that's where I messed up.
It could be a neutral, electrically neutral compound, and then accept the electron, and then be an anion. Or it could be a cation and accept the electron and become neutral.
Can it be an anion and just have a higher negative charge? Or it would be hard to accept, wouldn't it, if it...
Yeah.
The more the student talks, the more information the tutor gathers about the possible sources of the student's problems. In this scene, Charles exhibits the kind of patience that is often needed to give the student time to outline what is and what is not understood.
The zeros and all that stuff, I don't understand how to find the zero of something.
Okay. That's cool.
And I understand synthetic division, but I also don't, like the max and minimum stuff, and so I've got to go over that and the domain, because I always forget how to find the domain. Even though we've gone over that like a billion times, I still can't remember how to find the domain.
Let's watch some other scenes of tutors listening to try to diagnose the student's problem areas.
Your equilibrium constant, your K, is 100, which means what?
It's greater than 1.
Yeah. So which way does your reaction proceed?
Okay.
More.
Let's see. K equals the products of reactants, right?
Right. What else does it equal?
Rate of forward over rate of reverse. So it's greater than 1, that means the rate of the forward is greater.
Right.
So this is going to happen a lot more than this way than it is this way.
Think about that.
So if the rate's bigger, wouldn't it mean
The rate of the forward. Right.
You'll get it
You
straight
said it.
on.
Yeah.
Okay, so this is going to happen a lot easier than that way.
Right.
Let's just go through these. Make sure I can get them all down. Okay, let me see. See, trigonometry, which is 6-1. I did pretty good on that.
Did you?
In Algebra 3 last year, so.
Okay, that's good.
That shouldn't be a problem. This has really got me hemmed up.
Okay. So I'm gonna take this. That's 16, negative 16. I'm gonna add it over here.
You're gonna add it?
Yeah, it's negative. So I'm gonna add it.
But, okay, let's take out this term and rewrite it as negative 16t squared.
Okay.
Students gain confidence when they realize they understand concepts well enough to express them verbally. The verbal expression of the ideas also gives the tutor the opportunity to provide positive reinforcement, which further enhances the student's confidence.
An oxidizing agent is one that is reduced.
Right.
And then a reducing agent is one that's oxidized. This type of electrochemistry type stuff, the anode is what's going to be losing electrons, is therefore it's the oxidizing agent. But it's the reduction part of the reaction.
Yeah, that's exactly right.
Okay.
Is there another one like that? Or do you understand?
Sure. Yeah, I'm understanding. It's kind of tricky. I mean, it's not really, it's just the words and like figuring it all out.
Okay.
So likewise, if the more negative it is, the stronger reducing agent is going to be.
Right, right.
Which means it's going to be oxidized.
Good.
All right. I gotta keep like saying that to myself.
Let's review the important benefits of student verbalization that we have seen. When students verbalize, it gives the tutoring session an informal, conversational quality. Verbalization clarifies thinking and helps students focus on their own specific learning problems. When students verbalize, they tend to ask more questions. Sometimes, hearing their own questions will help students find their own answers. Student verbalization is also important for the tutor. The more the student verbalizes, the more likely it is that the tutor will be able to diagnose the student's misconception or confusion. Finally, students gain confidence when they are able to verbally express an idea. Tutors can help by adding appropriate levels of positive reinforcement.